Okay, for my presentation, I'm going to be talking to you about heat, thermal energy, and three methods of energy transfer. First off is heat, because it's a term that we often misuse and misunderstand. Heat is present when there's a difference in temperature between two objects. Take, for example, your hand and place an ice cube in your hand. The energy from your hand is going to be transferred into the ice cube and cause it to melt. The measurement for heat is 1 calorie, which is also equivalent to 4.186 joules. And the calorie represents the heat needed to raise 1 gram of water by 1 degree Celsius. Next, we're going to talk about thermal energy. Thermal energy is the sum of all the kinetic and potential energies present in an object. You're also going to hear this referred to as the internal energy, but both mean the same thing. Okay, you may be wondering, how can we distinguish between heat, thermal energy, and temperature? Well, temperature is the average kinetic energy of the molecules in an object, whereas the thermal energy is the sum of all these kinetic energies. Okay, so you could have a glacier that has a higher thermal energy than a small hot nail, just because the glacier is so much bigger, but the small nail is going to have a much higher temperature because the average kinetic energy of those molecules is going to be a lot higher, because once that nail is heated, they will be moving at a very high rate, and thus increasing the average kinetic energy, which in turn increases the temperature of the nail. And then heat is just the transfer of the energy due to the difference in temperature, so that's not to be confused with temperature. Next up is the specific heat. Specific heat is different for each object, and it is the heat required to raise 1 gram of any substance, not just water, by 1 degree Celsius. And the equation that we use specific heat in is Q equals mc delta T. C is the variable for specific heat, and we'll do an example later on involving specific heat. But now we're going to talk about the three methods of energy transfer. First off is conduction. Conduction is the collision of all the molecules in an object. For example, you take a fire stick and place it in a fire. One end of that stick is going to become very, very hot, and the molecules are going to be colliding at a very high rate, and they're going to continue colliding, and they're going to move down the stick at that rate, heating it as they go on. And the rate of heat flow is proportional to the difference in temperature between both ends. And in the equations for conduction, there's going to be a variable K. K represents the thermal conductivity of an object, and items with a large K, such as metals, are going to be very good conductors, whereas items with a low K, such as wood or cotton, are going to be very good insulators. The next method of energy transfer we're going to talk about is convection. Though liquids and gases are not good conductors of heat, they can transfer heat rapidly via convection. In convection, the heat will flow via a mass movement of molecules from one place to another. For example, a forced air furnace in your home. The air in that furnace is going to become heated, and then it has a fan that blows it throughout the vents in your house, and it distributes it throughout all the rooms in your house. And the last method of energy transfer is radiation. Radiation, unlike the other two, does not require a medium. The most present example of radiation is the sun radiating the earth. The sun radiates earth with visible light, and also rays that are not visible to the human eye, such as infrared radiation. The rate of radiation is the temperature of an object in Kelvin raised to the 4th power, which you'll see later. Shiny surfaces reflect radiation, whereas dark surfaces do not, and they absorb, which is why on hot summer days it's not a good idea to wear dark clothing, simply because it's going to absorb even more heat and create you and cause you to become even more warmer than you already were. Another instance where we use radiation is in hospitals. They have thermographs where they can measure radiation levels in your body, and They use that to detect tumors because that will show a imbalance in radiation. They can see that on the graphs. And now we're going to take a look at a couple different math problems involving